Alrighty. Hopefully someone watches. Might just go offline if no one's interested, but let's see. This lesson's pretty much the basics. The book uses PyCharm and Python, so that's convenient because I already like to use PyCharm. Let's make a new project. And let's see. How to program course. Shorten that a little bit. And hello! Hi, person! Welcome! Everything else is right. Taking a second to create the VM. La, 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 la. Fix that up so I don't have any issues with Windows Defender. And let's pull up the Python console. So Python's what's called an interpreted language, mostly. There's basically two types. Compiled languages like C, C++, technically Java, I think, because that's compiled. Pretty much compilation takes all your instructions you type in your program and processes it all at once to give you like a full, executable file. Interpreted languages, generally they'll go line by line, kind of like a little bit like a batch file. It's not like it doesn't need to be converted all at once to something. Python and as an example, like I said, kind of. JavaScript is. A lot of languages that are, there's kind of some subtlety because a lot of languages that are interpreted in theory will do some compilation behind the scenes, especially if you're writing like entire script files. And other languages, this might be an example, but other languages can do what's called just-in-time or JIT compilation, and that's kind of a mix. It's not really that important what it does exactly, because we're just at the beginning here. let's write ourselves a program. I'm gonna, let's see, can I make this bigger font-wise? Gonna see if I can. Okay, I think I found it. Settings, editor, font. And let's just increase this a bit. It's a bit big. Alright, hopefully that's a bit easier to read on stream. Oh my god, that looks blurry to me. Moment. Is this blurry to y'all? Oh, okay. It looks better on the stream. Looking at it in Stream Manager, it looks all blurry and crappy. So again, please let me know if you're having trouble reading. I can make this bigger. So print, and in your parentheses we put the argument, which is going to be a string. And strings have to be enclosed in either double quotes or single quotes. The only difference is that if you use single quotes, you can then use double quotes inside it all you want. Whereas if I wanted to use single quotes, and see, I'm having trouble even putting them in. See how that turns not green and kind of lights up red all over the place? That means it's thinking this is two empty strings with a bunch of crap between them. And you can, does Python have there's got to be an escape sequence. Ah, there we go. Just had to put it there. Or we can put an escape character, which is the backslash. And that basically tells Python, hey, the next character usually means something special, but this time it's part of the string. So anyway, that's really it about strings for now. Oh, other than the fact that a string is a string of text, like characters, like this. Some languages define it a little more loosely, but Python, it's text. And so this is an entire program here. that's not what I expected. There we go. Now it works. So that program just prints out hello world to the console, which is either this, or if we were to put it in a script and run it at the command line, it would print to the command line. And that's gonna be the focus of a lot of our first programs. You can do you can make GUIs in Python, but that's a little beyond what we're doing now. Let's see. And then alternatively, you can put it in a file. And call it hello world. Just checking something. Alright. And to tell... Now, this sometimes works funny, especially under Windows, or doesn't work quite right, but whatever. You can put a hash and exclamation point here. This is technically a Unix style path, but it works on Windows like it's what you're supposed to do. I don't know why. And so, now we can basically type programs line by line into here, or we can also make a file out of them and run them all at once. And this this line with a hash alone. Oh, by the way, this shebang thing only goes at the top of the file, and that basically tells it this is like a program you can execute. So, like in Linux or whatever, you can, type the name of the program, and it'll run like a like any other executable file, as long as you have permissions. Like I said, on Windows, it doesn't always work like you want it to, but I'm doing it anyway. Anyway, this here is a comment. As you notice, there's no exclamation point. Comments start with the hash in Python, and that basically says, hey, just skip over this line and ignore it when you're compiling or running the program. So that's kind of just to make notes for yourself or for other people who have to work on your program. Oh, and there's that issue with the quotation marks again. And if we save this, and we run it, it prints them out. And it skipped over these lines because these don't do anything. And if they weren't comments, they wouldn't be valid Python anyway. That's what this red squiggly line means, is that there's a problem. So that's easy. whatever you want to print. So let's see what the exercises in this book say. Bookmark. Actually, we'll just make a new file for this. Chapter 1. So this one's got a few little exercises. Let's see. Asking what the output would be from this code. And this can be pretty useful. Let's see, first one is print 1 plus 2 plus 3 plus 4 plus 5. Three double star 2 plus 4 double star 2. Whoop. Right, and there's a few more that are different. I'm just going to write all these out so I don't have to keep looking at the book. And last but not least, this one. So let's go through these one by one. As you can see, aside from my from PyCharm telling me this isn't good style, there's no problems with it. Python, as you can see, you can do math pretty straightforwardly with arithmetic. So 5 plus 4 plus 3 plus 2 plus 1. It's 15, I believe. And we can always check our answers. And that's absolutely right. Now what's this double star mean? That is exponentiation. So it's like the caret that you would write like doing out math by hand. And so this is 3 squared plus 4 squared. 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 is 25, I do believe. Yep, right again. And just like when you're doing any other kind of math, like a calculator, you can use parentheses to group things. So normally this would be 15 plus 2 if we didn't have the parentheses, but of course we add the 2 first to get 7, and 3 times 7 is 21. And we're on the money. As for this one, since this is a comment, it has that hash symbol, it's not going to print anything. Let's see what happens if we do this. Yep, none. So 1/2 plus 1/2, 1 divided by 2, same as 1/2. Should be 1. Sometimes there can be some weirdness with floating point numbers, but I think Python tries to compensate for that. Yep, 1.0. No problem. And then this double slash is your integer division. So when you divide integer-wise, it will truncate any decimal. So since 1 divided by 2 is 0.5, it'll chop off that 0.5 and get 0. So this should print 0. Yep. So now we got this really big number in the billions, mod 2. That looks complicated, but it's not. Because modulo means the remainder of this number divided by this number. And since this number is odd, it's not going to divide evenly by 2, so the answer is going to be 1. And if this were even, it would be 0. So that's an easy way to check if a number is odd or even if you have to. And let's see, to find the number of items in 8 dozen. Well, we know there's 8 of something, and we know that there's 12 items in a dozen, so 8 times 12, and that's 96. To find and print the number of weeks in 80 days, so we don't want to count a partial week, or we could say 80 divided by 7, and we'd get 11 point, a lot. But if we just care about the number of weeks, like I was saying, and we don't want to get any partial weeks, then we can do this. Use the integer division operator, and that just gives us 11. And then to print out I love Python. That's pretty straightforward. We just did that with hello world. And this isn't my first program, but I'll go ahead and indulge them. And we don't have to bother running this, because it's not going to do anything anyway. And that's the whole first chapter. Next one is variables, operations, and input-output. One sec. Oh, excuse me. Thirsty. So this goes over some of the internal aspects of memory. And there's all kinds of memory. Technically, even... I'll just go from the inside out. So even your CPU, even without any of your modules, has some memory in it. Those are called registers. And that's where the registers are where your programs put data that the CPU needs to process. Pretty straightforward. And then there are a few, usually layers of cache, C-A-C-H-E, not cache money. And that's on the same IC as the CPU. And that's super short-term memory, and unless you're doing real low-level stuff, you don't really have to worry about that. And then your main memory is what you usually think of when you think of memory, your RAM. That's basically your computer's short-term memory. It gets wiped whenever you return it off, but it's kind of your working space for programs. Oh yeah, and as the book reminded me, memory that's cleared when there's no power to it is called volatile. And then you have secondary storage, which is technically also a kind of memory. And that would be your hard drives, your solid-state drives, your USB sticks, stuff like that. And again, technically, it's memory, but it's not as fast as your RAM, so it's not ideal for like a scratch place. And then you could call stuff like cloud storage, network storage, you could call that tertiary if you want. So now we get to variables, because variables are, you know, kind of a box you can put information into. That's a super simplification, but it's not a bad one. Let's make a new file for chapter 2. And so like say we have a program like, even a real simple one, like our one to print the number of weeks in 80 days. What if you wanted to find out like a different number of days? Obviously it would suck to have to edit the file every time, so that's where variables come in. So let's assign a variable, or two variables actually. Well, a variable and a constant, but Python doesn't really have a way to distinguish them built in, which is fine because that's how Python works, kind of. So we're going to call this days in week. The name of your variable goes on the left, then a single equal sign, and the value. So days in week is 7. And the reason that's in all caps is because it's a constant. And that's just kind of a way to tell things that are supposed to be constant from other variables. And as you can see, hopefully, I wonder if I can make the font bigger on this too. Checking. I'll have to look into that later. So days in week, it shows us here, since we have the console up. It'll show us all our variables, and that's the name, and it's 7, and it's an integer, which is the data type. An integer is a whole number, basically, like 7, 13, negative 27, 0, anything that doesn't have a decimal after it. And when you do this with the equal sign, it's actually not an equal sign per se, it's an assignment operator. It says whatever's on the right, we're going to take its value and assign it here. And since we have a value stored in here, we can also use it in other statements. So we could say, this is kind of pointless, but we could say days equals days in week. And we have days, and it's equal to 7 also. So basically, your variables can substitute for, whatever number or string or other object you want to work with. And then let's say, well, let's start with 80. And this is totally valid. You can reassign to a variable, and it will just forget what was there before and assign the new value. So now days is 80. So now we can type oops, that was backward. Fortunately, when you screw up, you can just fix it. So that gives the same answer as before, but if we reassign days, say 120, and then we run this line again, you get 17 instead of 11. Because now days is 120. Fun stuff. And let's just kind of go over the elementary data types real quick. We've seen integers. And there's also there's also decimals. Let's say num equals 10 divided by 8. And that gives us 1.25. And notice instead of int, it says float, because this is what's called a floating point number. It has a decimal part, and the decimal can be relocated to a certain extent. Now, in some languages, floating points have range and precision limits, but I believe in Python, if your number can't be represented in an actual floating point, it will use like an arbitrary precision decimal format. So unlike some programming languages, you don't have to worry as much about imprecision. Although don't write a whole program based on that, my statement of that. And then the other type, let's say hello equals hello world, and that's a string, abbreviated str, and that's just a string of text basically. It's a string of letters threaded together. And some languages will also have like a separate character type for single characters. Python doesn't. And some languages are what's called strongly typed, so you have to actually say what kind of data type the variable is when you declare it, and then it's fixed. But Python isn't like that. One, obviously we don't have to say what the data type is, but also we can say hello equals 5, and it becomes 5, and an integer. Now, obviously you can store numbers either as a string or an integer, and generally which one you want to use depends on, like, is this number something I'm going to do math with? Or is it something where, like, the representation and the order have meaning, like a phone number? Because you're not gonna, unless you're like, programming for a telephone exchange, telephone company, and you're actually writing code that assigns numbers, you're not really gonna do math with a phone number. So you can do that and add some formatting if you like. And there you have a string. And then 5551234. This is kind of a more, without formatting. And then, let's see, foo is 5, and bar is 5, but a string. So what happens if we add them together? Uh-oh! We got an error, because it doesn't make sense to add an integer and a string together, because they're different. Some languages, PHP, JavaScript, will do this. I hate it. It can lead to really hard to diagnose bugs if you're not careful. On the other hand, if we add the two strings together, we get the string 55, because if you take a 5 and then you stick another 5 on the end, you get 55. So you can't do math with strings like you can with integers. So like a string you'd use for like an account number, social security number, stuff like that, where the order and like identity of the digits are important. And kind of like that intimated, you can use the plus operator to add strings together. Well, actually, you're not adding strings together, you're concatenating. That's what it's called. You stick one on the end of the other. So we could print hello plus comma world, and we get hello world. Just sticks and glues them together. And as you can see up here, and I didn't really point it out before, you can also assign an expression to a variable. So you don't need to like we didn't need to declare a variable for 10 and a variable for 8 or whatever and divide them. We just said 10 divided by 8 is the value. And you also might have noticed, even though when we made days, or when we declared it, we said it was equal to days in a week, when we reassigned to it, that didn't change the value of this. So when it comes to stuff like numbers, strings, a value is a value, and it's changing one variable with that value isn't going to change anything else. Oh, I just learned something fun. You can't add a string to an integer, but you can multiply it. So if say we put my name in a string, and then we print name times 5, we get my name repeated 5 times. So that's kind of an easy way to generate longer strings out of text. Can be useful. And then the next thing is input and output. And we've been doing output this whole time. That's what that print statement is. It takes what you put in the parentheses and prints it out. And there's a little bit of subtlety to it. You can print more than one thing. Like instead of adding these together with plus, I separated them with a comma. And it sticks them together. And that's getting into function arguments, which we're going to do a bit later, it looks like. And it doesn't matter if you have a space, although it is more readable if you do. And then we've got another function called input. And that lets you get input from a user. So this is going to be a few lines. So let's put it in a file so we can make it a little easier to comprehend. So our first line and so when we use input, we use it just like any other expression, like a math expression that we assign. And we put in that in parentheses. And we can also enter a prompt. So we can say like, enter a value, put a space. And basically this works just like in principle. This is just like if we said 10 divided by 8, except instead of like instead of just dividing a number, it goes and asks the user for one and substitutes it for this. And so val1 will become whatever the user puts in. And then we can print it. That's our output. And you don't have to give a prompt. You can just say And this is one of those places where the comma can come in handy. We have to put a space in here for reasons you'll see, but we don't have to here because we're using the comma. So let's save this and run it and see what happens. Oh, wrong button. I want to run this file. So here we go. And as you can see, it puts your insertion point right on the end of the string. So we need a space or else it'll be bunched up against the colon and that doesn't look good. So we put in Bobby Tires. And notice that without a prompt, here this is just waiting for me to say something. It didn't let me know that it wants input. There are cases where you might want to do that, like if you've printed out your instructions in another command statement. But here it's just kind of confusing. And then we type girls, and it prints out, you entered girls. And since when you use the comma, it puts a space between your values, we didn't have to include one in the string. Moving on. Oh! I almost forgot. You can also include a new line if you want a string to appear on more than one line. So we can say and the new line is \n. And like, if you're used to like other languages, you might be thinking, hey, this is Windows. You need to put \r\n. But Python will detect what OS you're using and use the correct line ending. So you just put \n, and that's all you need. Oopsie. And since I'm going to use a single quote in here, I want to use double quotes, so I have to escape it. And we get the message on both lines, or on 2 lines. And so this is where type starts to be a thing. Now we can also do input in the console, and it'll work. We don't have to run a script, so I can say foo equals, sorry, foo is assigned. One of my professors in when I went to school was always like, it's not equals, it's assignment, don't say equals. Input, enter value 1. And see how we get this different prompt here? That's how it lets us know that we're not typing in Python commands. We're giving input to the program. So let's say let's enter 12. And as you can see, foo is 12. But notice that it's a string, because any input that you get from the user is going to be in the form of a string. Hi! Hey Pixie, how you doing? Glad you can make it. Pretty good. I was like, streaming video games is really fun, and like I prefer it to playing by myself most of the time, but I'm there's kind of a glut of streamers because of the COVID, and I'm not making, like I don't expect to make like money off of that, so I figure I better brush up on my programming stuff. And so let's put in 8 for a second value. And you might have guessed what's going to happen based on my previous explanation, but if we say, if we print the sum is, and then foo plus bar, we get 128. And that's definitely not 12 plus 8. So, yeah. Yeah, I was kind of like that, but I'm like, I don't know, I like being able to talk to people and stuff, and I like trying to teach people stuff, so if somebody learns, it's cool. So, let's change bar to a decimal just 'cause. Say 8.12. So we can convert our numbers with these little special built-in functions. And all those are is the data type. So you can see like int, stir, float, those are what you type. So let's say we need foo to be, well, that's an integer obviously because there's no decimal point. So let's say foo equals int foo. This is totally acceptable, by the way. You can use a variable on both the left and the right side, and it will do all the stuff on the right before it assigns to the left variable. So like, this will take 12 and convert it into an integer and then store it back in foo. We could put it in a different one, but I wanted to show this off. So now foo is an integer. And here's one of the reasons the int float difference is important. Because if we say, like, c equals int bar, actually, just like any expression, you can put this anywhere and it will use the value it gets. And as you can see, that's not an integer, so it gives me an error. So we gotta say bar equals float bar. And that worked. Now it's 8.12 and that's a float. So now if we print foo plus bar, oh, there's what I was talking about with floating points. So notice how 8.12 plus 12 really ought to be 20.12, but we get this really long repeating number instead, and that's because not every decimal number can be represented exactly in floating point. Like, you know how in decimal 1/3 is like this, except the 3's go on forever. That's because 1/3 is a number that can't quite be represented in decimal. Same thing with floating point, basically. Like in binary, you just can't quite express that 0.12. You get a repeating decimal, just like or like a really big, kind of weird number, just like 1 divided by 3 in decimal. So in Python and in most programming languages, you really shouldn't compare floats for equality. You need to leave some wiggle room, and that's not really something we're getting into right now, but it's important. It's important to know that that can happen. So this one gives us a few short little programs. Oh, more than a few. Oh, excuse me. Message. So program 1 here. Sorry, this book is kind of small, so it doesn't, and it's like a square bound, so it doesn't lay flat easy. Another message. Oops. E equals 15. Oh, I keep doing that. So here's a new symbol. A plus equals B. So we've got 10 and 15, and we got this thingy. And what plus equals does, that adds B to A, and then assigns it to A. And let's just comment this out real quick. In PyCharm and most good IDEs, you can do that with a command. And so my prediction, we start with 10, and we add 15 to it, and assign that back to A, and print A out. We should get 25. Yep. And 2. Alrighty. So we start with, this is as good a time as any to point out, programs with a few tiny exceptions that will make sense when we talk about, by the time we talk about them. Programs just go from like line by line in exact order. And sometimes what my professor used to say under the sheets, It will do some optimization and won't do everything exactly like that, but it will, assuming the program, assuming the program is written correctly, act like it is. Like you'll get the same result. So anyway, we start with A being 10, B being 15. Then we assign B to A. So 8 becomes 15 now. Then we assign 1 to B. And since A and B are separate variables, this isn't going to affect A. So this should print 15, because that's the last thing that was assigned to A. Awesome! Oh yeah. So we get A is 10, B is 15. We multiply A by A, so that's 100, because of order of operations. And then we add B to get 115. Yay! This is such arithmetic, but I still feel good when I get something right. So, like before, we got A as 10, B is 15, and guess what this is? Just like our plus equals above, times equals, we'll multiply A times the right side and store that back in A. So this time we got 10 and 15, and because now this multiplication doesn't happen until just before the assignment, so it's going to do all of these calculations and then the multiplication. So it's not going to be like this. We got 10 plus 15 is 25, and then we're going to multiply that by 10 and get 250, and then we're going to print that out. Let's see if I'm right. Of course I'm right! Yeah. This is all really easy math. But that's cool. If one person learns from me doing this, I will be so happy. Equals float A. And then, excuse me, print B. So we got 10. Then we're going to convert that to a float and store it in B. And then we're going to print B. And that is, B is correct there. I checked. So my prediction is we're going to get 10.0. since if it's a float, I think it prints the decimal no matter what. But let's see. Right again! Good old number 6. This one's pretty straightforward. We get a string that's the number is 10. Then we convert it to an integer, and we print it out. So it's going to print the number 10. And as you can see, you can use variables just like regular numbers. And it prints welcome home. I forgot to make a prediction. Oops! I knew that would happen though. We've done it before. I don't know if this is a proofreading mistake or... Oh, that's not an error, that's just a warning. Never mind. Not a warning, but my IDE telling me that's not very good readable style. And now, this should work the same, because an equal sign, and like any operator, isn't valid to put in a variable name, so it knows that this isn't part of the name. So we should get welcome home, except since we're concatenating them directly, it's not going to put a space in between. Yep. So that's a thing to look out for. Whoopsie. So we've got a string 10 and a string 15. And then we're going to concatenate those together and store them in C. And remember from earlier how when we add strings, we concatenate them? So C is going to be 1015, and then we convert that to an integer, and it's going to print 1015. Yeah. Okay. And the next exercise is in the book. We got some prompts. More simple stuff. I'm probably going to blaze through this pretty quick. changed the gender of the night because I can do that. Alrighty! So this is easy. Set the price of bread to be $2. Goes 2.00. And that's totally fine. Let's get rid of all those variables on the right that we're not using anymore. And as you can see, you can do whatever with the decimal places. And it'll just store 2.0. So if it's something like money, then it's totally fine to do this, because it's kind of more readable. So given a price for a loaf of bread, bread price, and a price for a block of cheese, cheese price, calculate the cost to buy 2 loaves of bread and 3 blocks of cheese. So we already assigned bread price in the last question, so you can pretty much just leave that alone. I assume cheese is going to be more expensive than bread. I'm just going to say $5 because the exact value doesn't matter. So the cost to buy 2 loaves of bread and 3 blocks of cheese. Total cost. And then bread price times our 2 loaves plus cheese price times our 3 blocks. Make sure nothing else there. So 3 cheeses is 15, plus 2 breads is 4, so we should have 19. And we do! 19.0. Let's comment that so it doesn't all run. Get a user's age, that's easy. Don't forget the space. And don't forget the variable either. Oopsie. So my age is 17, and it has been for the past 17 years. Simple. I'm not really 17. And so we're going to write our most complex program yet. So let's say, obviously we need to get the name from the user. And then we need the characteristic. And then we stick them together with what else we got to put in the name. And since the commas put spaces in between, that's a straightforward way to do it. And this will stick together lady name the characteristic and put the spaces in between them. So let's make sure it works. Lady Nekohime the Horny. Totally works. And next we move on to conditionals and Boolean expressions. And those are kind of really important. Sorry, just doing a little reading so I don't get too ahead of myself. Oh, excuse me. Oh, pardon me. I think I'm going to finish this chapter and see if dinner's ready. And if I got time after dinner, I'll do some Bloodborne. So we're starting with conditional if-then statements. And that kind of sounds like a mouthful when I say it like that, but it ain't. By the way, you don't need this for your program to work, this shebang. That's really just so that your operating system can know where the Python interpreter is to execute it. Again, don't ask me why this also works on Windows, because I don't know. So let's do like an example of an if-then statement. I'll just use the one from the book because it's pretty easy to understand. And we're just going to write this out in English. And I'm going to assume this is Fahrenheit because if your temperature goes above 80 degrees Celsius, then you've got a problem. Whoops. So that's pretty straightforward. If your temperature is below 60, turn on the heater. If it's between 60 and 70 and you're not like, and it's like daytime, turn on the heater. And if it's above 80, you definitely want to turn on the AC. Because, wow. Excuse me. So, let us start with something very simple to kind of show you the gist of how it works. So notice how I say if true and I capitalize true? That's because true with a lowercase t isn't a thing unless you make it one, which I wouldn't. True with a capital T is a Boolean value true. And normally, you would not ever use it like this in an if statement, but this is good for illustrating like what Booleans are like. So if true, print turning on the heater. And you'll notice there's an indent here. That is how Python keeps track of what's called a code block. Like, if we want to do something else as well, if this is true, we can put it at the same indent level. And so how if works is it takes whatever expression is after if, and if it's true, it does what's in here, and if not, it doesn't. And since true is always true, it's going to always do this. And this colon is important because that marks the end of your true-false expression. So let's change this to if false. And it lights this up and tells me it's unreachable, which kind of gives the game away. But false is always false, obviously. So this will never happen. As you can see, no output. And then let's back up a tiny bit. And let's take off this indent. So since this is true, this is going to happen. And this is going to happen regardless. So we're going to get the same output. Ta-da! Now, if we change this, again, this lights up to tell us it will never happen. It will skip over this, but since this is not indented, it will print that. And that's not a statement within the if block, but whatevs. So say it's not enough just to do or not do something. Say we want to have something different happen if, depending on if our thing is true or false. So we could say if true, and then say we want to do something like I was discussing, if this is not true, we say else. Print temperature is fine. So with true here, we run this, and we get turning on the heater. If we switch it to false, run it, temperature is fine. So else happens if your if that it's attached to is false. And then we can nest if statements within each other. So I can say if true, again, you'd never really put true or false there, generally, but for demonstration, it helps to show off the difference between you know, how the control flow works. So if true, print it is cold. And then inside that, see how the second if is indented like this? This means that just like the print statement, this will only happen if that is true. And it'll happen in sequence. So it'll print it is cold, then it'll do this test here. So as you can see, you can have an else in an embedded or in a nested if. Again, if this is false, it will never reach this statement, the if statement, and so it'll never do this even though, like, regardless of this. And we'll show you. So again, and with PyCharm, it's easy to see which code is going to happen and which won't. So true, again, is true. So it's going to print it is cold. Then it's going to move on to this if. And since true is still true, it'll print the heater is already on. It'll skip this else, because it was true. And it'll also skip this else, because this was true. And just like we said, we get it is cold, the heater is already on. So if we change this to false, it's going to skip over this entire block. And it's just going to print it is warm enough. Ta-da! Because again, this if-else here is nested inside our outer one. And so if we skip to the else, it's not going to run any of this, so it's not going to do this check, and neither of these will happen. So you can get arbitrarily complicated with this. Usually at a certain point, there's going to be other constructs you want to use. And so let's start making this a little more more like a real program. Wait. So let's set a variable. Temp is low equals true, is set to true. And just to show you, let's kick up the console. True is a Boolean value, and Boolean just means it's either true or false. True or false, one of two values. And the other value, of course, is false. Still a bool. And see how it doesn't light up either side now? It's because in principle, this could become false before it gets here. And so you can kind of see now how this is going to work, because we can store true and false in a variable just like anything else. And we can just evaluate that with our if statement. And since temp is low is true, it's going to print turning on the heater and nothing else. And if we change this to false, we get temperature is fine. Just like before. And so, if we're talking about if-else statements, we really ought to talk about comparing things, because that's going to be a lot of what you're doing here. So let's assign a couple things. Assign 1 to A, assign 2 to B, also assign 2 to C, and now we're going to test them with some greater than and less than stuff. And if you remember math, that's pretty much works like you'd expect. I'm just going to do this again so that it actually appears in the console in order. These are 3 variables, and they're also on the side here for reference. So, is A greater than B? Well, is 1 greater than 2? Nope. Is A less than B? Is 1 less than 2? Yep. Is A greater than or equal to B? 1 is not greater than 2, nor is it equal, so that's false. A less than or equal to B? A is obviously less than B, so that's going to be true. Is B greater than C? Is 2 greater than 2? No, because they're equal. Is B less than C? Again, they're equal, so no. Is B greater than or equal to C? Well, given what we were just talking about, I'd say it's equal to, so that's going to be true. And is B less than or equal to C? Well, it's equal, so again, yep. And now, we've got equality. And remember, since a single equals sign assigns a variable, we can't use that to test equality. We have to use a double equals. So does A equal B? Does 1 equal 2? Nope. And to test if things are not equal, you use this symbol, an exclamation point, and an equal sign. Is 1 not equal to 2? Yep. Is B not equal to C? Is 2 not equal to 2? Nope, because they are equal. And again, something to keep in mind, if we forget the double equals and put A equal sign B, that assigns B to A, and now A is 2. So look out for that. Okay. Ooh, this has got a few exercises. All right. We don't have to assume, because we will. Got a message. Alrighty. C is 2, like before. Would these Boolean expressions be true or false? Yeah, it's not going to print outside of the console. So we got to wrap it in print. Hmm. My friend hurt her neck. I hope she feels better soon. Oopsie. Again. Phew. I wonder if they talked about Boolean operators in the lecture video. I'm not doing those because they're 30 minutes per lecture and I pretty much know this stuff. So I'll check up later. So let's look at this stuff. Is 1 greater than 2? Nope. Just going to put my prediction here. Is 1 equal to 2? Nope. Is A not equal to B? Yep. Is 2 equal to 2? B equal to C? Yep. Now, is D less than E? Huh. Well, that's kind of weird. Let's see what happens if you compare strings with these operators. Hmm. 5 is less than 6. All right. All right, we're starting to see a pattern here. So 5 is less than 6, which you'd expect. 7 is also less than 6, which you wouldn't expect. And syzygy is greater than 6. So the way strings work when you compare them is lexically. Lexicographically, if you want to talk fancy. And what that means is it'll go letter by letter. And this is not a complete explanation, because there are some subtleties to it, especially with other languages that have different symbols and writing systems. But basically what it does is it goes through both letter by letter, and there's a quirk with lowercase letters, but if the first letter of the one comes before the matching letter of the second, then it's less than, because alphabetically it comes first. And then if it's, so S and S are the same, so it just moves on to the next. And E comes before I in the alphabet, so that's also true. 7 comes before 6, lexicographically. And that's also why syzygy is greater, because The s's match, but y comes after I. Now, so y is capital 6 less than lowercase 6. Well, let's interrogate a little more. Oh, sorry, that was a bad example. I'll just use 9, because that's a good number. Obviously, 9 comes before 6. Not in most cases. Um, but what about... Wait, why are they different? Because in lexical order? Or, like, sorting order like this? ASCII order, I guess? Capitals always come before lowercase. So that's why 6 is less than 9 if it's not capitalized, but greater if it is. So now we know how to talk about these string ones. So is D less than E? Well, capital O comes before capital T, so I'm going to say true. And we'll check all these. Oopsie. Is E less than F? Well, the first letters match, but W comes after H, so that's going to be false, because E comes after F, or 2 comes after 3 when you do it like this. And likewise, D less than G, that should be true, because D starts with a capital, and this starts with a lowercase. And is G less than E? If it were capitalized, it would be, but it's lowercase, so it comes after. Alright, and we haven't seen these yet. Not takes a Boolean value and negates it. So not true is false, and not false is true. Sorry, I'm thinking about making truth tables now. So first we do the bit in parentheses, because parentheses work just like they do in math. Is A equal to B? 1 is not equal to 2, so that's false. And not false is true, so this is going to be true. And or is true if either side is true, or both. So is B less than C Is 2 less than 2? Nope. So this side is false. And is 2 greater than 2? Nope. So this side is false. And false or false is false. In fact, that's the only way or can be false. So a plus 1 is equal to b is on our left side. And is kind of the opposite of or. Well, no, it's not. But it returns true if and only if both sides are true. So a plus 1 is 2. 2 is equal to 2. So this side's true. And then is b less than c? Nope, so that's false. Not false is true. Both sides are true. True and true is true. And this is our most complicated one. I actually need to remind myself of this, because this is actually something I don't remember off the top of my head. Oh, wait. Nope, there's parentheses. Never mind. So in your parentheses, we got a less than or equal to b. That's true, because 1 is less than 2. I'm just going to use this as scratch space. And then is b less than or equal to c? They're equal, so this is also true. True and true is true. And I don't even need to do the other side, because I know this is true. Because if one side of an OR is true, then we don't need to, it doesn't matter what the other side is. Because OR is true if either side is true. And this, unless you use a specific special operator to tell it not to, this is actually how the computer thinks too. If it gets to something, if it gets to like an OR, and it evaluates one side, and it's true, it won't even bother to do the other. And likewise, if you have an AND, if the first side evaluates to false, then false and anything is always false, so that's always going to be false. And that's called short-circuiting. Short-circuit evaluation. Really wish I could copy and paste off a paper. So let's see if the answers line up. False, false, true, true, true. False, true, false. True, false, true, true. Just as expected. According to Keikaku. Keikaku means plan. I tagged it AMA, but nobody's asking anything. Also, there's only one person watching. Total cost is $100. Days is assigned 3. Cost per day is assigned total cost divided by days. If cost per day is greater than 40, not 30, print to expensive. And here's another little thing. If there's more than one possibility, you can do ELIF, short for else if. That's something you can do instead of nesting, because if you did this with nesting, you'd have to duplicate stuff. So else if cost per day is greater than 30, and else it's a total bargain. So we got $100 times 3, and then it's going to divide the total cost by the number of days. So the cost per day, oh wait, no, backward. So 100 divided by 3 is going to be 33 1/3. And the way if ELIF works is it evaluates each one at a time, and the first one that's true is the one it runs, and everything else is ignored. So, since cost per day is 33 1/3, it's not greater than 40, so we're going to skip this. But it is greater than 30, so it's going to print reasonable cost, and then it's going to skip over the rest. So even though the cost was also greater than 20, this isn't going to happen, because this came first, and this was true first. If ELIF takes the first true statement it finds, or true expression. Statements are different. And if none of them are true, and there's an else, it'll fall back to it. So let's test. Remember, we should be getting reasonable cost, according to my valuation. Yay! So here's number 2. Age is 67. Income is 10,000. If age is greater than 70, oops, didn't need that. If income is less than 15,000, print eligible for benefits. Else, if income is less than 20,000, up to 100,000, need that colon, Back that ass up. And there it is. Alrighty, Rooney. So age is 67, and income is 10,000. 67 is not greater than 70, so we skip over all of this and go to the else. And 10,000 is less than 20,000, so it should print eligible for reduced benefits. Oopsie. Yep. There it is. Oh, excuse me. Alright, and we're done with that section. And we got our code bits. Okay, my numbering went off because I was not numbering them. Okay, this is 14. Wait, no. This one is. Rewrite the code in a simpler way by using a more complex Boolean expression. And an elif statement. Compare a variable user guess to a variable hidden answer. And tell the user whether the guess is too low, too high, or exactly right. Ooh. Oh, this is a good exercise. Pardon. Fun. Checkaroonie. All right. Let's do it up. Hmm. See if age is greater than 70 and income is less than 1,500,000. Okay. Aha! Hey, I didn't notice these. Those are the same. So, the only way they're eligible for benefits is if their age is 70 and their income is less than 15,000. So let's make that our condition here. Else if and notice that you're eligible for reduced benefits if your income is less than 2,000, regardless of your age. Oops. So reduced benefits, you get them if your age is greater than 70 and your income is greater than 20,000. And since this test happens first, it will, or less than, sorry. And since this test happens first, it will skip over the aleph. Whew! That's a lot easier and we didn't have to repeat any strings. Let's see, we should get reduced benefits here. Yay! So this is the same as our chunk of nested ifs. It's just a lot more concise and we don't have to repeat ourselves. Alrighty. So hidden answer, let's say 69 so far, and get some input from the user. Enter your guess. And if int user guess is equal to hidden answer, whoops, that goes outside the parentheses. Else, if int use, actually, you know what'll save me having to write this? I can just do it here. Ta-da! If the user guess is less than hidden answer, then it's too low. And if it's not equal, and it's not less than, it has to be greater than, so we can just say else. Alrighty. Now the leap year problem. So if it's divisible by 100, it's not a leap year, unless it's also divisible by 400. And if it's divisible by 4. Alrighty. So let's do this as a series of nested if statements. So, if, let's say, let's just use all these examples to test ourselves. This is kind of a kind of like test-driven development here. Basically, you take your expected inputs and your expected outputs. So 2000 should be a leap year. 2100 is not. 2004 is. 2001 is not. And we can use these with all of our programs. So let's put them up here. So, if the year isn't divisible by 4, it's not a leap year. Always. So remember how we talked about using the modulo operator to check if a number is odd or not? Same principle here. So if year mod 4 is not equal to 0, then it's not a leap year. Else, I'll invert that. So if the year is divisible by 4, we do this. Otherwise, we know it's not a leap year. So if it's divisible by 4, then if it's divisible by 100, then it's not a leap year. If year mod 100 equals 0, and as we said, if the year is also divisible by 400, then it's still a leap year. Yeep year. Yeet year. And if it's divisible by 100, but not 400, it's not a leap year. And then if it's not divisible by 100 at all, now I could do this a bit more simply, but I don't want to introduce a bunch of crap. So let's just test them in order. So with 2000, this should be a leap year. Oopsie. Oh, we forgot to even try that. Let's try our guessing game. 12 is too low, as we expect. So a good thing to do when you're testing something like this is do like just a little off in both directions. Because let's say 68. That should still be too low, which it is. And 70 should be too high, which it is. And 69 should be just right, which it is. Okay. So now let's try this out. With 2000. 2000 is a leap year. Let's try it with 2100, which should not be a leap year. Correct. And 2004, which should be a leap year. Yay! And 2001, which should not be. Yay! It works! So let's try it with if else. So if year mod 4 So like before, we'll start with the most specific. Here's something about Python. There's a keyword pass you can use that doesn't do anything, and I like to, when I'm planning out my stuff, just fill it in so the parser doesn't confuse itself and puke out and tell me all my stuff is wrong. So if year mod 4 is equal to 0, and so if a year is divisible by 400, it's also divisible by 100. So we can just say if year mod 4 is 0 and year mod 400 equals 0, print leap year. If year, actually, this would be simpler a different way, I think. If year mod 4 is not equal to 0, print not a leap year. So if it's not divisible by 4, we know it's not a leap year. And if it's divisible by 400, and not 100, or 100 not 400, don't know if I need these, but can't hurt. So if it's divisible by both, actually, duh. I just mentioned this. We don't have to check for 100? Because if it's divisible by 400, we know it's divisible by 100. Yeah. So the way this is going to work, notice how concise it is compared to this. So if the year isn't divisible by 4, then you know it's not a leap year. If it's divisible by 400, then it is. And remember, if it's not divisible by 4, it won't even check anything else. It'll just go straight to this. And that's the same thing here, just inverted. So if it's not equal, we do this. And then if it's divisible by 400, then it's also divisible by 100, so we don't even need to check that. And it's a leap year. And remember, this goes in order. So if it's divisible by 4, and it's not divisible by 100, but it is divisible, or it's not divisible by 400, and it is divisible by 100, it's not a leap year. And otherwise, if those two special rules don't apply, and it's divisible by 4, it's a leap year. So let's just chunk all these down here to make it clearer what we're doing, and make sure everything works. That's test-driven development. You take your inputs and your expected outputs, and you make sure they all work. And as you can see, we have an input for each case. We got 400 divisible, 100 but not 400, divisible by 4, but not 100 or 400, and not divisible by 4. So that's every case. And let's see if we were right. We should get true with 2000. Yep, that's a leap year. We should get false with 2100. Yep. 2004 should be true. And 2001 should not. Yay! Our code works. And now, as a single if statement with a complex Boolean expression. Here's our test case. So, if year mod 4 equals 0, and year mod $400, or nope, not and, I'm having a brain fart, it's getting late. I've been doing this for a while. I feel kind of dumb though. So it's not a leap year if that or that. I know how I can do it. Think if year mod 4 is not equal to 0, or year mod 400. Whoops. Oh, I'm not thinking it through right. and not year mod 100 equals 0. Hmm. Oh, duh. So if it's divisible by 4, oh my god. My meds are wearing off. It's been a while since I'm doing this again. But I can't bitch. I should know how to do this faster. Pure mod 4 0 or year mod. Alright, so let's actually step through the process here instead of me just floundering. So if year mod 4 is 0, that has to be true. And if it's divisible by 400, oh, I think that is it. We'll find out though. No. So if it's divisible by 400, then it is. And if it's divisible, no, it's not. And year is divisible by So so if this is true, so this has to be true, and it must not be divisible by 100 unless it is divisible by 400. Let's fill that in. Some parentheses to make it a bit clearer. So, first of all, the year must be divisible by 4, because if it's not, it's definitely not a leap year. And so this needs to be true. I'll kind of write this out. Let's go with, let's say 2000, just as an example. So if it's 2000, that's divisible by 4. So we got true and something. Or something. All right. Year divisible by 100 is true. And not year divisible by 100 is false. But it's also divisible by 400. So this is what we end up with. False or true is true. True and true is true. Yay! So with 2100, let's walk it through again. So 2100 is divisible by 4. So that's true. It is also divisible by 100. So not true is false. And it's also not divisible by 400. So our other side is false. So false or false is false. True and false is also false. So that's right. So, oops. Let's go with 2004. 2004 is divisible by 4. It is not divisible by 100, so this is false, and the not inverts it to true. And we're done, because true or anything is true. True and true are also true, and that's good. Now try it with 2001. So 2001 is not divisible by 4, and that's all we got to do, because false and anything is false. And let's make sure our program agrees with us. We should get leap year for this. We should get not leap year for this. Oh, duh. That was important, and I left it out. That's test-driven development. You do your test cases, and if it's wrong, you know you gotta fix something. It's not a leap year. Make sure our first test still passes. That is a leap year. Make sure 3 passes. And 4 should be not a leap year too. Yay! Now it works. So as you can see, this is a little tricky if you're not that familiar with Boolean, but it's also way more concise than this. And I'm done for the day. It'd be cool if more people would watch, but I had a lot of fun. We're gonna get into much, much cooler stuff eventually. Let's see what's next. Basic program development and testing. Oh, cool. This is kind of related to what we were talking about. Yay! Okay, everybody, old person, thanks for watching. Love ya. Oh, you know? Alrighty. Love ya, thanks for watching. See you later.